First of all, I would like to show the interface. The new interface that we've been working on, actually, it's in a ribbon structure. We're calling it ribbon structure because previously we had all tools, but we were not able to see the names of the tools. It was just some buttons that we use, but you should get used to it. So now with the new interface, actually, you can see the buttons that we use for many operations. You can see their names, and we separate those tools into other tabs. The good thing is actually in that structure, you can customize. What I'm saying about customizing. So, for example, if you would like to move some of the tools, you can do it from here, like estimation and simulation operations will go under the 3D tools, or it will go under the window. So when you click it, you will see that estimation operations going to move forward to the window. So with that, actually, you can customize how you would like to use the software. Also, there's a quick access tool which you can put commonly used tools for you in here. For example, the navigation tools are quite useful. So by just adding them here, it's a quite a good aspect, to be honest. And also, for example, from the 3D tools, let's say sectioning, so getting a cross section. You can add that to quick access tool, and when you use it, it will get its shape as well. So with that, actually, you can easily manage the software. I made some practices before I started, but today, besides from the interface that we prepare, we're going to talk about some of the features of NETPROMine. One of the most common thing that usually people ask to me about the estimation processes. So besides from the interface that we have, we're going to talk about the estimation methods. If you would like to talk about the estimation methods, I think we should start from the beginning because all of the estimation can't be done without proper information. So that's why I prepared that sample data. And today we are going to talk about that data and we are going to learn it. We are going to get some statistics about it, and we will see what we can do for estimation processes. So first of all, we have some statistics. If you add the borehole and if you would like to get a general idea, the first thing you can do is getting some statistics. For example, the length statistics. If you choose the grade, by the way, this is a Chrome project, and the levels, the red parts on the borehole that you see actually contains grade information. But I don't have any statistical information that how long my levels are in that project. Therefore, as an attribute, I'm selecting a grade, and when I click it, I'm getting its statistics. So the minimum level that I have that contains a grade is 25 centimeter, and the maximum, the highest level that contains grade, Chrome grade constantly, is 51.6 meter. And also the other statistical information which can be used in the variogram operations later on, like variance, standard deviation, and skewness. So those information are crucial for me. If I want, I can check export statistics, and when I close it, I will have those statistics in a notepad. So I can copy, I can use that statistics later on. Moving forward, the other statistics that we have, which is quite important also, is the grade statistic. So I do have a grade information, the Chrome content inside those levels, but I don't know how well it's distributed or what's the minimum and maximum content of grade. So when we check, we can see that in different 90 samples, I do have minimum 2.33 grade content as a percentage. And the maximum grade content that I have is 33.55. So that kind of statistics I can get from the software. Besides from that, by selecting a couple of boreholes, you can also calculate the weighted average attributes. So the selected boreholes have average 11.4 almost grade content in average. So that kind of statistics I can get from the beginning. What I would like to do is actually make it more visual. For that, I'm going to use the borehole information, right click on the borehole, and row sample displaying. This one will display grade attribute to me in a 3D view. So it's going to be much more meaningful. Also, in the legend, I can see that grade distribution. So the software gets the grade information and it's divided into 4 different pieces. If you would like to make it more meaningful to you, you can always edit its range. For example, grade, minimum 0, maximum 35, and the slot value will be 5. With that, I'm going to split that information into 7 equal pieces now. Okay, so in this levels, I do have grade information distributed. If I uncheck the borehole, I will still see that grade information, its levels, and how well it's distributed. So if we check in those levels, I do have the grade information, and this is actually their length. So this length, I do have a grade information, and it's in between 10 to 15 grade range. By using that, actually, we are getting some information about the data. So more or less in those levels, I do have a grade information, and I'm going to make a model that represents that distribution, that levels, and that grade information. What I would like to achieve, getting a geological model, then turn that into a block model, and then assign those values to the block. So at the end, we are going to assign all that grade information into a block model. By the way, I do have a borehole and borehole access, but I made a filter of it. So if I remove the filter, you will see all of the boreholes, and you will also see that those levels are matching with the red parts that I have on the boreholes, which is the lithology that I would like to make a model. So from the legend, if I give some transparency in here, especially, you can see that I do have great information in between 20 to 25, and I do have small grade content in here. I mean, I said small, but in terms of length, actually, it's small. It's like maybe 1 meter or 1 meter and 20 centimeter-ish. So in here, I do have grade information in between 10 to 15, and in here, I do have 20 to 25. So that row sample display actually represents my model, my future model that I would like to work on. So once we create the implicit model, that represents my lithology or the levels that I have grade information. Let's see it again. Okay, here. is is a model that I'm going to work on. And as you can see, that implicit actually produced by covering those levels. Those levels in the boreholes actually has a gray content, and I made a model by using those levels. The last thing that I had to do is making an estimation. Once when I'm able to assign that borehole values, the grade values we have in boreholes, I will make an estimation. So with that, I will be able to estimate how much volume of a material that I have in terms of grade. So this is my model, and basically if I check its properties, now all that I can learn is volume information. Let's check. Okay. In here, I can see that I do have a geological model, which is 146.8 almost thousand meter cubic ore. So this is the value of my ore. By the way, this is coma, so my actual volume is 146,000. Okay, besides from that, now we are going to move forward to the block modeling part. But before that, I also would like to show you the composite operation and creating a histogram graph for that model. So if we check, it's, sorry, from here, histogram by using all of the boreholes. Okay. If I select grade attributes as an attribute that I would like to use, so I will see that there's a graph, and mainly my grade information distributed in between 0 to 21 in general, but I do have a bullseye point, which is in between 30 to 35. So it's a quite small part, and I know exactly where it is, but that's okay. In general, my model in between those grade ranges, and the average grade is 11.22 in here. Besides from that, we are going to make composite. With that, we would like to achieve actually distribution of grade information. So how it's going to happen, we are going to create composite C1, I'm calling it, and the length. If you remember, I had minimum 25 centimeter of length that has a grade content, and the maximum was 51.6 meter. I can also check its length information or attribute information from here as well while I'm making the composite or creating the composite data. Because what I would like to do to distribute that grade information into some levels. To explain it even better, I will use old friend paint. So let's say this is our borehole data, and I do have a lithology inside. So we are moving forward by using the logic. The logic inside is working like that. So while we would like to create the composite information, we are going to have some levels that contains grade information. Therefore, my grade information is actually limited in those levels before I made any operation. So I do have grade content, let's say 12. let's say 8.5 for this level, and let's say 15 for this level. So without making a proper distribution, it's going to be raw information. With the composite, actually, I'm dividing that information into smaller pieces. In here, I am selecting a length. So if I select 1 meter, that means I'm going to distribute that 12 grade information into 1 meter levels. So this level will be produced, this level, one by one. The grade content in it is not going to change inside because all of them going to be 12th grade if we don't have any other measurements inside this level. So in everywhere, I'm going to have 12th grade information. But what it does, it's actually providing us good information when we would like to assign those values into the blocks. Imagine we have a couple of blocks right here and right here. When we would like to assign some values into the blocks, we are going to read information from directly its level and also its level. If we have separate lithologies like that, we are going to read information from that and information from that. So basically, we are not assigning the average chrome grade of the borehole directly into a block. We are getting that information from certain levels, which we distribute after the composite operation. So I will divide those levels into 1 meter levels. And the acceptance percent, I will use 25%, which means, let's say I do have a lithology like 7.25 meter. So I know how the software is going to behave because it will create some levels for that, actually 7 levels, right? Directly because we have 7 meter. But what we are going to do for the rest of the 25 centimeter? If I select acceptance percent as a 25%, then that means, okay, if it's a 25 centimeter, create one additional level for that. But if it's less than 25 centimeter, don't even bother. Don't even create another level for that. Because I'm getting 25%, now I will create another level for that 25 centimeter. Also, if I have borehole and a really small 25 centimeter level, we are also going to create one composite level for that 25 centimeter level as well. So in here, whatever is grade, it's going to be shown also. Let's say 14. If we use higher information, we can lose that data. That's why I use the statistics minimum level that I have was 25 centimeters. So I also use 25%. I'm not missing any information in terms of grade. As attributes, I'm selecting the grade attributes. I didn't create any additional group inside the boreholes, which I can do in terms of managing the borehole data. I can separate boreholes into different groups, but I didn't. So ungrouped covers all of the boreholes, which is 94 different boreholes. When I click OK, we do assignment of the composite information. We do have some displaying options. I can display that composite distribution in 2D or 3D. So I'm selecting the grade. As a remark length, I'm using 10 meter. When I click OK, as you can see, I created that levels and now I'm displaying it. For example, this one. If you remember from the start, we had that raw sample displaying. And I also mentioned that that small part contains grade information in between 10 to 15, and this part was in between 20 to 25. So now I can see that when I make that composite distribution in every level, I can see what's the exact grade information for every 1 meter. So I have 12.13 in here and 20 in here, which is going to help me later on when I would like to make a distribution, when I would like to estimate the block model with my own borehole data. So like in this case, we are not going to get information from that level. We will get information from that level. So this block more likely in between 15 to 85, 15 to 8.5, not in between 12 to 15. So it's getting lower from that side. Maybe also from that side because there are no separation or no other information. So most likely we're going to use that level. But that actually affects the distribution, and also in the inverse distance method, we are going to create an ellipsoid. So when we create an ellipsoid, we are going to gather information from those levels, and it will also help us. Okay, turning back. So when we make the distribution, I do have great information for all of the levels. And I can also make 3D display, but it's quite similar to this one. It's a raw sample display, and the other one, the composite 3D displaying, is going to be composite 3D display, basically, but it will display the sample data instead of raw sample data. Let me show you. When we did the distribution by using composite, so the raw sample information we have at the beginning, which is 8.44. Totally fine. And now we do have a sample record in every 1 meter. As you can see, we made a distribution. So the display of the raw sample or sample is not going to change too much. More or less, they're close to each other. But of course, you can also do that. Let's make it. This time, we are going to use the 3D display. When we click OK. Yeah, quite similar. But again, it has different thematic ranges, which I can edit for making it more meaningful for me. 4 to 5. Okay, so now it turns to quite similar row sample distribution. And if you remember from the histogram graph, let me show you again, that bullseye point in somewhere I said I do have a material in between 30 to 35. So this is actually that part. In that level of a borehole, I do have small side. I mean, small part that has or that creates the bullseye point. Let's check the object properties of this one. So it has different levels, but in between 27.3 to 29.5, we do have chrome content, chrome levels, and the row sample record, as you can see, we do have a 33.55% chrome grade in it. So some people love to take those parts, some people don't. If you want, while we are making or creating an implicit model, you can also remove that small piece if you don't want to include it into your main ore body. So that small piece actually seems like it's containing some high grade information. Okay, now we know the data quite well, actually. The next step is creating a block model by using the implicit model to make a better estimation. Actually, what we create as a solid model also should be used quite well in the block modeling procedures. So at least as a volume base, we need to represent that implicit or geological model quite well. Therefore, we are moving forward to the blocking operations. So in here, we have a couple of options. There's a subblock criteria, which we can use to create blocks that has half size of the main block. So if I use subblock criteria 1, that means I'm going to half the sizes of the main block and I will create small blocks. What it does is basically near to the edge, let's draw our geological model. Okay, something like that. We do have the geological model. That means actually I'm going to have main blocks, most likely inside, but near to the edge, I'm going to create smaller blocks. With that, actually, I will be able to represent that volume even better. Let's do that operations. First, I want to use the subblock criteria, and the block model that I create will contain only blocks that has 4 meters in each direction. So it's going to be a cubic block. Okay, so as you can see, actually we kind of cover the volume, but some parts are not well represented, maybe. So let's check the information of that block. In a volume base, we created a block model that has 138,000 almost volume block model. So regarding volume, it represents the original solid model like 94%. Let's repeat that operation by using subblocks. Now, besides from the 4-meter blocks, I'm going to also place that smaller ones inside the block model. Let's do that operation. Okay. Even from the beginning that we can see it covered more. It covered the implicit model more, but let's check the statistics. Let's count on the math. So yeah, as it says, that block model has 142.2 thousand volume, and in terms of volume, it almost represents like 97% of the implicit. So in terms of representation, I do have a quite okay or quite good block model. Now, the last thing that we should do, actually, we should assign those values into a block model. This is what we would like to do. Okay, so I will get a row sample displaying again. Verify to 5. We will use and check that information later on. Maybe I can change the thematic range also, but yeah. Okay, now we do have a good block that represents the implicit model. We can start making resource estimation operations. I will get a copy of that block. Okay, so now we are going to use a couple of methods that we have for estimation processes, like nearest neighbor, inverse distance, and kriging. Therefore, I can rename the blocks like nearest like inverse distance method or kriging. Okay, I put some name to them, so I will make estimation by using those methods into the blocks that has the same name. Okay, now let's talk about the nearest neighbor method. So basically for the nearest neighbor, you don't need any specifications. Like as long as you have the composite distribution, you can simply make the estimation. This first one is the nearest neighbor. And when you select the attribute, the grade, you can make a simple distribution. It's getting information from the closest borehole. That's why there are some clusters going on. For example, these blocks And those probably they got information from high grade levels, and they got that information directly from the boreholes and from the closest borehole. Therefore, we can see more clusterings. I mean, it's also not going to change too much, even if we added its thematic range. Let's add it. Let's make it 2 to 20. Yeah, like that. So the distribution, that clustering is not going to change too much. But here we can say that it changed a little bit because it got information from those levels. So it wasn't purple all the time. It was getting information from that borehole, and that borehole has great information in between 10 to 12, more likely. So this one contains 16 to 18. So yeah, this one has a 16 and the other one has 10.07. Okay, this is the simplest method. Basically, what it does from here, if you consider, it's getting the information from the closest level directly and make assignments. So if that levels are 12, most likely the block will be so close to the 12. And if another block that we have is close here, it will be more likely going to be 15. So it's getting information from the closest portal. But now we are moving forward to the little bit advanced method, which is inverse distance method. For that, we need to use an ellipsoid. Before that in NETPROMine, if you remember, we were not showing the ellipsoid, we were expecting the user to write some angles. But now we are also showing that ellipsoid so it can be manipulated easily by the users. So let's bring the ellipsoid parameters from here and click the show ellipsoid. So now we do have ellipsoid parameters in the block. So the first thing that we do, we are selecting the block. There's a one block on the screen. It will automatically choose its center location. It will recognize the block. And then we are going to create a layer for the ellipsoid that we are going to produce. And I select the blue color for it. And imagine those were no information before. So I will decide what is going to be the length of an ellipsoid, the width of an ellipsoid, and the thickness of an ellipsoid. So after deciding that, I can simply apply and bring the ellipsoid here. Yeah, it is here produced in the center because when we recognize the block model, first the ellipsoid created in the center. Let's give some transparency to our block so that we can see the ellipsoid even better. Actually, those angles were quite okay, but let's make some changes and see how it's going to affect the ellipsoid. So I change the length of the ellipsoid, and when I click apply, it will extend. So 50 meter. And if I change the direction, the azimuth, it will also affect my ellipsoid. So I need to decide what kind of angles that I would like to use. The first, we need to arrange the azimuth information. So if that azimuth is okay, now we're checking that from minus x side, or we're looking at the ore body from the side. So now I can also make arrangements for the deep information and the rake information. So the rake information basically helps us to adjust the ellipsoids in up and down sides. So my ore body follows a pattern. It goes slowly to the bottom. So that kind of information that I can use. But if I check the model from this side, the dip should be a little bit like that, because I do have higher thickness on that side. So rake the dip. Yeah. Now, it is looking quite okay, quite adjusted with the angle of the main ore body. So now we are going to make the distribution by using the ellipsoid, but if I want, I can also save that ellipsoid parameters to be used later on and load the existing saves of an ellipsoid parameters. But if we are decided to use that ellipsoid, basically, if we are confident about our ellipsoid, we can synchronize the settings. When we synchronize the settings, all that information will be transferred here. Let's make it so I want you to see that 50 meter we used for the x-axis of an ellipsoid. So when I synchronize the settings, it will change automatically. Also the angle information, right? So I got those settings here. And when I click OK, it will do the estimation. All right. So now we do have an estimation, and let's check. According to grade, I am editing the thematic range. Okay, this is what we have as a distribution. I also would like to edit the thematic of 3D. Quite the same, like 0 to 22 and dividing into 2 meter, 2% ranges, right? Okay. So now let's see them both. So, okay. I have some part of the lithology here. It is in between 18 to 20. Right? We didn't get that bullseye point because we didn't use blocks quite close to that borehole. We kind of remove that piece. And let's check the other parts. So I can see the color of the blocks as well. I can see the transition, right? So in between 0 to 22, 0 to 22, it has to be quite similar when we assign that information into the blocks. So let's remove the 3D, right? Let's bring it back. Or maybe we can remove its area borders. Right? So the actual grade content of a borehole and its level and the distribution itself. Those are quite matching. Even in this side, it's getting purple-ish blocks. In the middle, we do have yellow levels that we have in the middle. We are going into a yellow, but in general, it's the green. In here, it's the orange part that we have. So it's quite fitting. The estimation and the sample displaying are quite fitting, which means we're actually doing something okay in here. Yeah. Therefore, inverse distance method is actually quite useful. One of the most used estimation methods. And the logic behind is actually it follows the pattern of a geological model. And we are creating an ellipsoid to gather information from around. But we are not gathering every information. When we create an ellipsoid, like that, for example. Okay, so like that, we are getting information from those levels, basically. Not from here directly, and also levels in here, and also information from other blocks as well. So when we would like to estimate that ellipsoid visits every particular block, this one in this case, our main block will be this one, and the ellipsoid will be produced around that block. When we would like to estimate another block, the ellipsoid will visit other blocks as well. So for example, if it would like to make an estimation for the other one, it's going to look like this. Yeah, so ellipsoid actually visits every block's center and then make the estimation. For example, block in here, it's going to look like this as well. So it's gathering information inside the ellipsoid. If we have a borehole, yeah, we are going to get information from the boreholes. If we have blocks that we already assign some values, it will use that information as well. So with that, it make the assignment. On top of that, that ellipsoid direction, ellipsoid angle is compatible with the main ore body, which allows us to make more accurate distributions, or it provides us more freedom while we're making the estimation. So, but at the end, we are assigning values inside the blocks, and this is what we would like to learn. We already knew when we create the implicit model, we already knew the volume, the potential geological model volume, but we didn't know how good it is, or what's its quality. And it can be also, let's say, gold content in it, or it's a coal project, and we can see the calorie information of the coal. So we didn't know that. We knew that there are some volume as a geological model, but we didn't know what could be the potential estimation. So if we check the IDM with the block model reports now, reports, block report, sorry. So yeah, grade. And the density information, let's add 2.23, okay. The density information will just allow me to see the tonnage information. And yes, so according to the grade range, the thematic range, we are getting volume and tonnage information regarding the block. So I knew the model that I produced, the block model that I produced, has that amount of volume, but I didn't know what's the distribution. So 44,000, almost two of them. In between 8 to 12 grade range, I do have 88,000 material, and the rest is actually distributed into other ranges. So in every thematic range, I know how much material that I have. That grade range can be adjusted, and you can get a report if you would like to see that report in different intervals. Let's do it. We have to edit the thematic range. I'm creating a new numeric range for grade. Let's make it 25 and divide it into 5% intervals. Reports, block reports. So I changed the thematic range, and also I got a new report regarding that thematic range. So I do have really small amount of material, higher than 20% of a grade. Okay. After the estimation, I do have the grade information inside the blocks, but that doesn't mean we can't assign any other values, because you can assign any information to a block model that we have as attributes. If you have, let's say, attribute information like moisture, ash, other metals, right? Then you can make assignment. For example, let's add, actually it's going to be hard to add another attributes, but let's say you have another attributes like, I don't know, iron content, for example. In your analyzer reports, you might have also iron content, which is totally fine. What is going to happen if you also have the iron content? When you would like to create the composite file, you will also see the iron attributes. So according to that iron attribute, you are going to create a composite. When you create the composite, when you distribute that iron content into the borehole as well, along with the chrome grade, and then you will be able to do estimation. First, you are going to do the estimation for the chrome grade, and then second, that iron will be shown in here when you make the composite. So after that, you're going to select the iron and do the estimation for the iron. So you're going to have grade information and iron information inside any block later on. So yeah, this is actually the process. Now, one thing left, which is the kriging. Let's do kriging distribution as well. We do have a block model that's totally clean. If we check its object properties, sorry. Yeah, if we check its object properties, we will see that besides from density, it doesn't have anything. And density also, we didn't assign any density, it's just default. So yeah, that one doesn't have any information. So to make kriging estimation, we need to create a variogram because kriging also use those variogram settings and the ellipsoid parameters together to make estimation. It's using together the both variogram and the ellipsoid parameters to make an assignment to the blocks. So because of that, we are moving forward to the variogram part. So in the variogram, there is a one classic variogram, which brings a table. And inside the table, we can add vertical and horizontal variograms. And let's say, okay, adding the one direction. So we are calculating the vertical or variogram. We are selecting the attribute that we would like to use. We are deciding tolerance and bandwidth. And regarding the variogram results, actually we are checking the variogram and then we are deciding which angle we had to use as a variogram. So this is the classic one. Let's make it at least, okay, put some parameter here and show you how it's done. So it's manually bringing one variogram to us in a vertical degree, -90. But now we also develop the variogram map feature. With that, basically, you can automatically calculate the attribute is the grade attribute. When you click apply, it will create semi-variogram values. It will provide you a chart. And from that chart, we can actually select the anisotropy direction that we would like to use for variogram. Okay, the direction that we would like to use is actually the longest axis. So if you check which side will go further, this side, right? So that's why the 60 to 240, that side looks like our anisotropy direction, the longest edge should be in between here, or maybe 70 degree. Yeah. So when we understand which angle that we can use by checking that, then we can automatically make that operation. So it will calculate and provide us the variogram in two different angles. Yeah. Besides from 60, it also produced the 150, but I am not going to use that. Okay. I unchecked that information. So I would like to use that one, the 60 degree. So when we click on the model, it asks the nugget effect. If you remember at the beginning, we also get some statistical information, the variance, skewness, and other statistical information. So this is the part that those information will come in handy. You can use that parameters to decide what's going to be your variogram limits, what should be, and according to that, actually, you can make decent variograms. But the main idea from the graphic, actually, selecting a nugget effects that your variogram polyline actually might start. So by clicking on the points, you can directly select one level, but you should also select the variogram and where it starts. So from the point, from here, we got some level, which is 14.7. If I want, I can manually adjust that level. So I can make 13.700. 13.2. Okay, looks like quite fine. Could be the beginning point of the polyline. And for the structure, we need to select the seal value, and usually from the graph we select the point that our polyline turns into another direction. So this is the first breaking point of the polyline. It's turning into another direction. So the seal value at the level, the highest level is 21, which is okay. And the method that I would like to use, Gaussian, exponential, or spherical method could be. And the range is actually making our drawn polyline closer to variogram polyline right here. To make it closer, you need to increase the range like this. But we don't also want that polyline to get inside a variogram polyline. So it should follow from the outside. So we are trying to get closer that polyline as much as possible. But if I use something like 24 range, so it's not quite fitting the variogram, right? So 54 will follow that polyline even better. I can use that range. I can use that angle. I can use that seal value now. So those are my variogram information that I got it. When we click OK, it will actually create a variogram. So 60 degree. I didn't put any information into 150, but now I do create a 60 degree variogram with its information. So it's in our pocket. The next thing we should do, we should create a kriging to make a kriging estimation. So moving forward to the kriging operation. Basically, we create the variogram. So in the second tab, first one is the parameters, and the second tab is the variogram. So basically, we are going to delete this one. Yeah, basically what we have to do is select the structure that we create for a specific angle. So 60-degree structure that I created, I will select. When I select that structure, it will automatically get its seal value, the ranges, the angles that we used. So variogram part is filled, and the other part is quite the same with the inverse distance method, the ellipsoid parameters. And here it says parameter name, but it's a kriging name. So I will say K1. Kriging type, simple kriging or ordinary kriging, I can select. The attribute that we always use was grade, content of a chrome. And if I click show ellipsoid, I need to draw the ellipsoid again. Do I have to need that? No, because from the inverse distance, I can get the values, right? I did that ellipsoid before, so it's going to be the same ellipsoid. 18 and rake 100. Okay. So I do have the ellipsoid parameters here, and I do have the variogram parameters. When we click OK, we are creating the kriging. And from that kriging, we can do estimation for many blocks, basically. So if you click any block, select the estimation and kriging. By the way, you can create a lot of different kriggings as well. But while we are assigning, you have to select which kriging you would like to do for the assignment for resource estimation. So the first kriging that we create, we will select, right? And then we will click OK. It will do the estimation. All right. Editing the thematic range. Yeah. Again, that kriging is also good estimation method, well distributed, going to be quite computable with the raw sample data as well as the IDM. It's also a good distribution. We can see the transitions. Okay, now it looks simple, but yeah. So we can see the transitions in here in kriging also. Those are the good methods to be used to assign some values. And if you compare it with the raw sample data or composite 3D display, you will see that it's making quite good assignments. So just compare it with the raw sample data and the composite data. You'll more likely will get closer to its potential. You'll slowly get making more accurate estimations with time. So for that part, there is another tool that we can, it can be useful, which is not this one. You can check its histogram after making a distribution as well. and before that too, so you can compare histograms. And what else? Okay, in here, in that window, we do have variogram and validation methods, and we have a validation for inverse distance and the grading. If you do that, you will also get a report. It might take quite long because it's checking every borehole level, it's checking the blocks, it's just checking the assignment, etc. So in general, what it does is actually it's controlling the assignment, and eventually it's giving you the potential error that you might make. So in the report, you will see that borehole 1 estimation used for block 1, 2, 3. So different blocks, it's made an estimation we made. So the row sample or composite, in this case actually, comp data, let's say 15, and the blocks 14.7, let's say 15.2. So it calculates the potential error, and then it gives you a percentage, let's say 0.03% error for borehole 1 estimations, let's say. And then it does that operation for all of the boreholes, borehole and estimation, borehole to the block. So it calculates all of that, and then it gives you a final report. So borehole 1 is like that, borehole 2 is like that. At the end, eventually, it gives you, let's say, 0.05. I just wanted to make it different. Average, okay. Potential error. So at the end, it tells you how accurate your distribution is. So if you make, let's say, 0.5% or 0.005% in a general estimation, it's quite good, actually. So 95 or 99.5%, depends how you think of that percentage. So the estimation was accurate, 95 or 99.5% accurate estimations you do. So that report allows you to check also. Like I said, you can check the information by using the row sample data as well. We can check the distribution, how well distributed those informations are. And you can make some filtering to get some meaningful results, because filtering operations in the block modeling, it's crucial, and you can make a filter by using a lot of different criteria. For example, the grade. Show me the grade. Show me the block model that has higher than 15% grade, for example. Okay, those blocks. Maybe 10. Yeah, now at least we have more information. So what criteria we can add also? Show me the block model that has higher level than 435, let's say. Oh, sorry, I select the width, actually, not the Z value. Okay, it has to be block Z value. So block elevation. Okay, those blocks are higher than the specified level, lower than another level. Now, I create slides. So 15-meter slice by using elevation ranges, right? If you get a report in that stage, you will also get a report of filtered version of the block. So if you do assignments, if you do your resource estimations, you can make a filter and check different information by using filters inside NETPROMine. What else we might wanted to do? Maybe we can create an area and we can calculate block model volume or tonnage separately in some cases. I don't know. I will add inside boundary criteria. When I apply the filter, now the software will ask me to select an area. So now I will select an area 2. It's going to filter that part of the block to me so that I can check its reports once again. So it's changing dynamically all the time. But if I'm going to use, let's say, that separated block in the future, what I can also do, I can get a copy of that block. So it will get a copy of the filtered version of the block. So IDM filtered. Filtered IDM. Yeah. Okay. And then I will remove the filters on the main IDM method block that I have. Uncheck that one. And whenever I wanted to, I will check the filtered version of IDM. So yeah, this is how we do the estimation operations on NETPROMine. Now I will check the questions if you have, or I can get your questions